Now we go to safer cycling based on smart textiles. As I suppose I do not yet know the results of Salzburg research, Severin, Bernhart, Eva-Maria, Hollauf will tell us more about this. Simon, Julian, Nöbauer, Simon, Kranzer. I hope these are the participating agents, and probably there are more in the team. So I'm looking forward to your presentation. Thanks, Tom.
For this great presentation. It's also for bringing up how important the research on this is. So I will switch again to German. Danke auch an Raphael, dass
so thank you to Raphael that he has shown us what is existing already and who is working already in that area which we want to cover. So for our briefing, we have thought about the future communication between autonomous cars and warning signals for cyclists and how they could look like. As you have mentioned already, there is one team of the University of Salzburg in the makerspace, and we were also invited on Tuesday, thanks to Florian that he welcomed us. And the second team is from the University St. Pölten. They have worked virtually. I will present you then. And thanks to Severin, who worked with me with the teams, and I'm looking forward to the presentations now. And just to show us the framework of the ideas, and I'm really looking forward to what they did. And I'll give the floor now to the virtual team because they had a similar idea, that is to use radar for detection. Well, Eva gave the floor to the team of the university in St. Pölten. Who wants to join? Hello. Well, I will share my screen. Then let's start. Thanks for the introduction. We are a students team of the University of St. Pölten Masterclass Technologies. And we, who are we? This is Sarah Gartner, Schwarz David, and David Schaupp. And we decided to do safe cycling, and we present you now what we have done during these days. What are we going to present to you? We will show you how we found our concept and why we have chosen that concept. We will talk about dangers when cycling, possible solutions, and how can you diminish or decrease dangers of cycling. And we have done prioritizing of the ideas by analyzing the use, and then we made an analysis of the used cases, and we also made then an determination of the costs for a future development. What are the dangers when you are cycling? Well, we have a certain tool of different methods. For example, well, there are few dangers which we have found, which we have determined. There are 10 dangers. These are only some of them. Well, of course, there are more dangers. And how did we go on? Then we used the methods 6 through 5. Well, based on the danger during cycling, we have created 6 ideas. And we have then, with these ideas which have been generated, we have defined requirements. How do these requirements look like? We have 8 of them. We have described the requirements, and then we have again solutions or proposed solutions which you can install in your bicycle or on your clothes. And with the solutions, we also presented design proposals on the bicycle itself or on the clothes. And here we have different ideas, some different requirements which we have defined, and we also to show a transparent way how you can prioritize use cases. And that's why we did the use value analysis, which is quite difficult, but it's transparent and you can decide quite easily how to find a decision. Well, the procedure is you compare two pairs, you define criteria, technical feasibility, economic feasibility, how this could be accepted by the customer. Then you have a certain weight balance, and then you evaluate, then you do the real use value analysis, and then you define the subjects. We had here two use cases. The first use case, well, a bad vision, and then you turn to the right or to the left. The cyclist does not show the signal that he is going to the right or to the left. And the colleague will go on. Well, we also had how you can work with radar sensors and with ultra noise, ultra with ultrasound methods in order to detect cyclists better. We have also shown how you could install it. Every bicycle has lights in front and in the back side. Already linked with our system. Radar sensors on the back side, on the front side could detect cars that is dangerous. And the system we used for ESP, we used the ESP32, the sensor with a corpus and with batteries, and you can fix it on the bicycle where it does not disturb it. We just fixed it on the frame. Our concept looks like that. When cars are too close to the car, the light should get lighter and lighter so that the car driver sees that they are too close to the bicycle, and the cyclist himself gets a warning signal and a noise and acoustic signal that something is not going well. We also thought that we could link that with an app. The ESP32 has a Bluetooth connection, would work with the mobile phone, and then you can see how close cars are to the bicycle from behind. So here see the first proposals for your mobile phone. We could only work virtually. That's why we could not develop a real prototype. And so we wanted to do a virtual prototype, and I would like to show it to you. Do you see? Yes. Yeah, we see everything. This is a virtual structure. And we just use this UNO, then the ultra distance sensor, the ultrasound distance sensor, then a buzzer for the acoustic signal, and an LED, which is just simulating light. I'm not sure if you can hear it. That's the car. The car is getting closer and closer. The light is getting lighter. And then the buzzer starts giving an acoustic signal. And when the car is very close, half a meter, then the backlight starts blinking so that the car is getting attentive that they are too close to the bicycle. Well, and this is our simulation, and we can use that all these elements and do this in real life and have a real touchable prototype. Let's go back to the presentation. Then we did also a cost analysis, how much that would cost to have a functioning prototype with the app. And we did internet research to find out how much hardware is costing and how long the development will take. Well, and so we can finish our presentation, and we hope that I forgot now the word I wanted to say, and we hope that also this virtual concept can be realized in a real hardware. Thanks for your attention. Yes, we would love it if you could realize this. Maybe there is a possibility to realize it and show it in October. Eva and Severin, you had a second team. Yes, we had a second team in the makerspace. They are ready already, and they would continue if you want. Well, I have seen that they are here. Yes, I see Florian and his team. Hello. Of course, we also continued the challenge. Well, the main idea was to use smart technology, smart cars, but then we found out you probably sooner or later there will not be any labels anymore, because cars know how to behave on the street. And then with all this we started, so maybe we go there.
So the cars communicate with each other, and we need to integrate them somehow. So that's the idea. With the smart epics, we get the sensor to the people. Yeah, so that's technicians. Unfortunately, the sound is very bad. I can't really hear him. So we need a standard for security solutions. So there is a possible holding point. Security was very important. There are IT standards. So we crafted something. We can also show it to you. Would you please be careful to speak close, to be close to the microphone, because we can't hear you. Okay, I'll try. So this is our prototype. There are G sensors in it. And if I give my sign, the sign with my hand, it starts flashing. No, sorry, I held it in the wrong way. So if I make a sign with my hand, it starts flashing. And if I put it away, it should stop. Well, it stopped. And And later on, we might supply it with additional sensors. We can give them the point of time and the speed. And the system, so the system communicates, says that he or she wants to turn left or right. So it's a kind of indicating. And it starts flashing. So communication is between cars and bikes. We thought about continuing with this project. The day before yesterday, we contacted companies that might be of interest in Salzburg and around Salzburg to integrate them. And so to use not too much electronics. So we'll do our best to do it in an as inactive way as possible with the LED lights. So we will still have to play with that a little bit. And then we will continue with the crafting here. As I said, this is the information we gathered from the last 3 days. I'm fully aware that you could keep on talking about this for a longer time, and the first results are great already. So you will, in a few days, we'll see a first prototype, don't we? Won't we? It works. It works. Now, if I may give back the question to Severin and Eva, how are you doing with the development of this project? Because you have opened such a big field. Yes, absolutely. Well, thank goodness the teams. We had already worked out the first ideas, and we are really looking forward to knowing how it will continue with the team of the technical college. We were in constant contact to integrate the project. And Severin, could you give us any feedback here? Well, and our teams have done a great job. And the concept for the radar method was really exciting. And the same with GEMINI Makerspace. And it was a kind of smart textile glove. And perhaps this could also be developed into a jacket. And let's hope that a prototype can be worked out by next week. So we will definitely have lots of cooperation possibilities within Industry Meets Makers. So we have Salzburg, GEMINI Startup Race, Salzburg Research. So this can be really a great thing. I really do hope that we will see you again at the Industry Meets Makers on the 18th of October. So many thanks for this exciting week.